16 AI agents building a complete C compiler. 100,000 lines of Rust code. Result? A compiler that builds the Linux kernel on x86, ARM, and RISC-V. Cost? $20,000. Human team for the same work? $200,000 and months of time. This is coordinated AI agent teams. But here's what nobody mentions. Agent teams are one of two fundamentally different approaches to parallel AI work in Claude Code. Today, you'll learn the great divide between agent teams and subagents, when to use each, why both exist, and how to choose. By the end, you'll have a decision framework that saves time, money, and frustration. Let's dive in. Claude Code has two completely different ways to do parallel work: subagents and agent teams. They're not variations. They solve fundamentally different problems. Here's why both exist. Delegation can happen two ways. First, tasks that work in isolation and report back, like sending people to different libraries to research and return with summaries. Second, tasks requiring active coordination, like building a house where electrician, plumber, and framer constantly communicate. First approach, subagents. Second, agent teams. Neither is universally better. Using the wrong one is like bringing a sports car to a construction site. You'll get there, but it won't be efficient or cost-effective. The key insight: architecture isn't about capability, it's about communication. Subagents work in isolation and report results. Agent teams coordinate autonomously and share context. When you need isolation versus coordination is the critical decision for parallel AI workflows. Get it right, you move fast, spend wisely. Get it wrong, you waste tokens, time, and patience. Subagents are specialized AI assistants running within a single Claude Code session. Each has its own context window, system prompt, and tool restrictions. Critical part: they work in complete isolation. The flow: main agent delegates to a subagent. Subagent does its work using allowed tools, returns a summary to main. Full context stays in the subagent's window. Your main conversation only sees the summary. The advantage: context preservation. Test suite with thousands of lines of output. Subagent runs tests, analyzes results, reports just the failures. Your main context stays clean. The limitation: subagents cannot talk to each other. Spawn 3 to research different code areas. They work independently. Subagent 1 has no idea what Subagent 2 discovers. All coordination happens through the main agent. This isn't a bug, it's the feature. Isolation makes subagents efficient for research, exploration, and focused tasks where you only care about results, not process. You're trading collaboration for efficiency. Agent teams work differently. Instead of one session, there are multiple independent Claude Code sessions working together. One leads, spawning teammates that are fully independent agents with complete context windows. The lead creates a shared task list all teammates see and update. Teammates claim tasks, mark progress, complete them, create dependencies. When blocking tasks complete, dependent tasks auto-unblock. Self-organizing teams, real power, direct communication. Backend agent tells frontend, changed API endpoint from /tokens to /billing/tokens. Update your fetch calls. Frontend receives, acknowledges, updates code. No human intermediary. Lead coordinates. Creates team, defines task breakdown, spawns teammates with instructions, monitors progress. But once working, teammates operate autonomously. Claim tasks, coordinate, check in only when stuck. This enables true parallel work with real-time coordination. 3 teammates on database, backend, frontend, simultaneously, messaging as dependencies resolve. But autonomy has a cost. Token usage scales with team size. 3 teammates equals 3 times token consumption. You're paying for genuine parallelism and autonomous collaboration. The entire difference in one sentence. Subagents give you isolation and efficiency. Agent teams give you collaboration and autonomy. Everything else follows from that trade-off. Cost matters in production. Subagents, roughly 1.2 times baseline token usage. Extra cost is spawning overhead and summaries. Agent teams with 3 teammates, 3 to 4 times baseline. That's not overhead. It's running 3 separate Claude instances plus coordination messages. Speed differs too. Subagents work in parallel but synthesize sequentially. Each finishes, reports back, main processes. Agent teams achieve true parallelism. All teammates work simultaneously, coordinate in real time. Lead steps in only at decision points or blocks. Communication makes the difference crystal clear. Subagents, everything flows through main. Subagent A can't tell B anything directly. Main received from A, processes, passes context to B. Agent teams, direct messaging. Backend sends frontend an API contract. Frontend acknowledges and updates. Lead isn't involved. The insight, you're not choosing better versus worse. You're choosing architectures optimized for different communication patterns. Subagents optimize for no coordination needed. Agent teams optimize where coordination is the point. Subagents shine when preserving main context and workers don't need coordination. Concrete example, running test suites. Run tests in main conversation, output floods your context. 100 tests, 10 fail, you're carrying 90 useless passing outputs. Subagent solves this. It executes full suite, analyzes output, reports just the 10 failures with error messages and stack traces. Main context stays clean. Code-based research. Perfect use case. Need to understand authentication, database access, API routing, and unfamiliar code? Use the built-in Explore subagent. Tell it to research all 3. It explores files, reads code, identifies patterns, returns structured summary. All exploration stays in subagent context. You get architectural summary without bloating main conversation. Focused analysis. Code review. Create a code reviewer subagent with read-only access. Can't modify, only analyze. When you finish a feature, reviewer examines changes, identifies security issues, performance problems, maintainability concerns. This returns organized report with critical issues, warnings, suggestions. Analysis process isolated. This is the pattern. Subagents excel when tasks are self-contained. Verbose output needs isolation, and results matter more than process. Research, analysis, testing, documentation. You care what they found, not watching them find it. Agent teams dominate when workers need coordination and parallel implementation requires real-time communication. One of the clearest examples is cross-layer development, where changes in one layer affect others immediately. Building a payment system. Need database changes for transactions and balances. Backend API endpoints for purchases and validation. Front-end UI for billing and purchase flow. All interconnected. Backend depends on database schema. Frontend depends on API contracts. Subagents? Sequential or massive rework. Agent teams? Contract-first spawning. How it works. Spawn database agent first to define schema contract. Once delivered, spawn backend and frontend in parallel with schema context. They work simultaneously. Backend messages frontend directly. Changed endpoint structure for token purchases. Here's the new contract. Frontend gets it mid-implementation and adjusts. No intermediary, no waiting. Parallel debugging with competing hypotheses. Another killer use case. App crashes intermittently. Cause unknown. Spawn 5 teammates with different theories. Memory leaks, race conditions, database connections, event loop, error logs. The magic, they challenge each other's findings. Memory leak agent finds an issue. Race condition agent reviews and confirms or disputes. Through adversarial debate, they converge on root cause faster than one agent could. Multi-perspective code review. Spawn security auditor, performance analyst, test coverage reviewer. Same pull request, different lenses. Security finds vulnerabilities. Performance identifies bottlenecks. Test finds coverage gaps. Separate agents means no overlap, no bias. Thorough, multi-dimensional review in parallel. Decision framework that saves hours and thousands of tokens. Start with one question. Do I need parallel work? If no, use main conversation. Single agent workflows are faster, cheaper, simpler. If you need parallel work, next question. Do workers need to coordinate? Not would coordination be nice? Do they actually need to communicate for the job? If no, use subagents. You get parallel research, independent investigations, analyzing different modules, fetching documentation, and running tests. Workers operate independently, just report results. If workers must coordinate, agent teams territory. Back-end decisions affect front-end builds. Competing theories debate. Multiple perspectives reviewing same artifact with overlapping findings. Coordination is the value. Third factor, cost constraints. Do you have a tight budget or frequent workflows? Subagents might be only choice, even with some coordination needs. 3 to 4 times token usage adds up. Work around lack of coordination with explicit task definitions and some sequential work. Time constraints push opposite. Deadline and parallel work with coordination gets you there 2 to 3 times faster. The extra cost often is worth it. Calculate time value, make trade-off explicit. Sometimes spending 4 times the tokens to save 60% time is right. Simple framework. The main for single agent, subagents when workers don't coordinate, agent teams when they do. Factor cost and time as overrides. This works for 90% of scenarios. Here are some real numbers from real projects. A C compiler case study from Anthropic, canonical example of agent teams at scale. 16 agents, over 2,000 sessions, built a complete C compiler in Rust. Production quality. It compiles Linux kernel on multiple architectures. 100,000 lines. Cost $20,000 in API credits. Not cheap. But hiring a development team? 200,000 plus in salaries, months instead of weeks. We see here a 10-to-1 ROI. What matters? This is impossible for a single agent. The complexity, scope, and cross-component coordination required multiple agents debating, coordinating, verifying. The mistakes that waste the most tokens. Mistake 1. Using agent teams for simple research. Spawning 3 agents to find to-do comments? Massive overkill. No coordination needed. Use the Explore subagent. You get a clean summary at a fraction of the cost. Mistake 2. Using subagents for cross-layer implementation. Building a feature across database, backend, and frontend with 3 sequential subagents. Database builds schema. Backend builds APIs based on assumptions about the schema. Frontend builds UI based on assumptions about the API. Nothing aligns. You spend hours fixing mismatches that coordination would have prevented. Mistake 3. Spawning too many teammates. More agents doesn't mean faster work. Coordination overhead scales with team size. 3 teammates with 5 tasks each is manageable. 12 teammates is chaos. Task list explodes. There are messages everywhere. Agents collide despite coordination. 12 times token cost, maybe 2 times the speed. Diminishing returns hit hard after 5 teammates. Mistake 4. Not combining approaches. Best workflows use subagents for research. Agent teams for implementation. Subagents explore codebase and gather context. Return summaries. Use summaries to create detailed plans. Spawn agent team with that plan to build. Use efficiency where it matters. Coordination where necessary. The pattern. Using the wrong tool for the job. You need to match the tool to the communication pattern the task requires. If you found this valuable, 3 things. First, subscribe. I publish AI strategy content every week. Parallel agent patterns are critical for production AI systems. Second, hit the like button. It encourages YouTube to reach out to more AI strategists and architects with this content. These and other AI personnel need this knowledge. Third, ring the notification bell. Don't miss Part 2 and Part 3. The AI landscape evolves fast. You can catch insights when they are fresh. You learn the decision framework for agent teams versus subagents. Use it to architect parallel AI workflows with confidence. You now understand the fundamental difference between subagents and agent teams. Subagents give you isolation and efficiency. Agent teams give you collaboration and autonomy. Neither is universally better. The right choice depends entirely on whether your workers need to coordinate with each other. In Part 2 of this series, we'll dive deep into subagents. You'll learn how to create custom subagents, the best practices for different use cases, and advanced patterns like persistent memory and conditional tool restrictions. In Part 3, we'll master agent teams, setup, contract-first spawning, quality gates, and real implementation patterns. If you found this valuable, make sure you're subscribed because this 3-part series is your complete guide to parallel AI work in Claude Code. Thanks for watching, and I'll see you in Part 2.